Hi y'all, welcome back. I'm Pi, and today we're going to be taking a look at problem number 11 from the 2015 AMC 10B. Among the positive integers less than 100, each of whose digits is a prime number, one is selected at random. What is the probability that the selected number is prime? So I'm taking a look at some keywords here. I want to notice prime, I want to notice digits. And what I'm going to start with is got a set of numbers 1 through 100 because positive integers less than 100. Actually, it's 1 through 99. And we notice that there's going to be 1-digit numbers and 2-digit numbers. A 1-digit number only has that one place, and that must be occupied by a prime number because each digit is a prime number. And each of the 2-digit numbers spots must be occupied by also 2 more prime numbers. Now, what we don't know for certain is that this entire number is going to be prime, but we do know this one will be prime. So let's get started by listing out the prime numbers less than 10. So these are just going to be 1-digit prime numbers. 1-digit primes, and each of these primes might appear as a digit in these numbers. So we've got 1 is not a prime number, but yes, 2 is. 3 is a prime number, 4 is not, 5 is, 6 is not, 7 is, 8, 9 are both not. So this is all we have. We've got 4 primes. So for these 1-digit numbers over here, among the positive integers less than 100, if I just look at 1-digit numbers, then I've got 4 1-digit numbers that fit all the conditions above. Then let me look at how many 2-digit numbers I can make, and that's saying yes to repeats. So I'm going to say I've got 4 options for this first spot. This spot can be 2, 3, 5, or 7. And I've got 4 options for the second spot because I can repeat. It can be 2, 3, 5, or 7. So I'm going to say there's 16 2-digit numbers I can make, where each of the digits is prime. So I'm going to add 4 plus 16, and that gives me 20 total numbers less than 100, where each of the digits is prime. Now I'm going to try to find the probability that the selected number is prime. And all that's saying is really how many prime numbers are in this are out of this 20. So like I'm going to try to find number of primes out of 20, because I'm saying for any given number that I pull, what are the odds that I will pull a prime number out of the set of 20? So let's start counting the primes. I know for sure that these 4 that I looked at the beginning are all going to be prime because they're 1-digit primes. So that's 4. Then let me take a look at each of these other numbers that are 2-digit numbers with each digit being a prime. So looking at that, I noticed that in the tens place, I can have any of them, 2, 3, 5, and 7. But in the ones place, I can't have a 2 or a 5, which means I can only have a 3 and a 7. That's because if a 2-digit number ends in 2 or 5, that means it's going to be divisible by 2 or divisible by 5 respectively. So now I can just list out the numbers that I get from this because there's not that many combinations. So I get 23, 27, 33, 37, 53, 57, 73, and 77. Then I'm going to go through this list and see which of these are actually primes and which of them are not. So 27, hey, I know that's divisible by 9 and by 3, so that's not a prime. But 23 looks like it could be. 33 is divisible by 11 and 3. 57 is just 54 plus 3, and I know 54 is a multiple of 3 and 9. Then 77 is also divisible by 11. So just by some intuition and by thinking through about factors, I figure out that the only 2-digit primes that come from my restrictions are these 4. Again, that gives us 4. and that gives us 4 over here. So I have 8 of them are primes. Now I have to come back to my original and say, got 8 primes out of a set of 20 numbers, which simplifies down to 2/5. And there we go. Option B is 2/5.